The Sun formed approximately 4.6 billion years ago from a large, rotating cloud of gas and dust known as the solar nebula. The formation process is thought to have unfolded in several stages. Gravitational collapse. The solar nebula, likely disturbed by a shockwave from a nearby supernova, began to collapse under its own gravity. Formation of a protostar. As the cloud contracted, it started to spin faster and flatten into a disk shape. Most of the material was pulled towards the center, forming a dense, hot core known as a protostar. T-Tauri Phase. The protostar continued to accumulate mass from the surrounding disk. During this phase, it experienced intense stellar winds and ejected significant amounts of material. However, the core was not yet hot or dense enough to initiate nuclear fusion. Ignition of nuclear fusion. Main sequence over millions of years, the temperature and pressure in the protostar's core increased dramatically due to the immense gravitational forces. Eventually, conditions became extreme enough for nuclear fusion to begin. In this process, hydrogen atoms fused to form helium, releasing vast amounts of energy. This marked the birth of the Sun as a main sequence star. The outward pressure from the nuclear fusion balanced the inward pull of gravity, creating a stable star. Planetary formation. The remaining material in the disk surrounding the young Sun began to clump together through a process called accretion, eventually forming the planets, asteroids, and other bodies in our solar system. Solar wind clears the nebula. Once the Sun ignited, its strong solar wind helped to clear away the remaining gas and dust from the inner solar system. The Sun has been in its stable main sequence phase for about 4.5 billion years and is expected to remain in this phase for another 5 billion years before it eventually evolves into a red giant.